Hello guys, welcome to another discussion video. So in this video we're going to look at SDA 2022 chemistry paper 1. Okay, so guys, let's try to get the followers up to 1k, and also let's like the videos. Okay, all right, so question 21 says some statements about states of matter are listed. 1, liquid turns into a gas when heated. 2, solids are highly compressible. 3, particles in a liquid state can move past each other. Which of the statements are correct? Now we know that statement number 2 is incorrect. Okay, solids are not compressible. Okay, since already remember in a solid state you have particle arrangement like this. Now to be able to compress a piece of matter, you would need for the particles of that particular substance to have what? Spaces in between. So remember, compression is just taking away the free space between those particles and physically bringing them closer to each other. Okay, so therefore solids are already, the particles are already close to each other, so there's no space that we can take away. Okay, what about what? Liquids turn into a gas when heated. Yes, so liquids, when you heat liquids, the particles gain enough heat energy to escape from the liquid via the process of evaporation. Okay, via the process of evaporation. Then 3 says particles in a liquid state can move past each other. Yes, so in a liquid state, remember that the particles move past each other by sliding past each other. So you'll have a chain like this, and then another chain like that, and then this chain can slide past the other chain. Okay, so that's the movement that you get in a liquid state. Remember all those key terms of how you describe the movement in a gas, in a liquid, and then the in a solid. Okay, so in a solid we don't have free movement, but we have vibration in fixed space or places, and then in a gas you have free movement, and then here you have movement by gliding and sliding past each other. Okay, so therefore the answer is going to be what? The answer is going to be option 1 and option 3, which is what? Which is going to be B. So that's the answer. 22 says which subatomic particles are found in the nucleus of an atom? So remember your atom, A for atom, is structured this way. So this is the nucleus. In the nucleus we have the neutrally charged neutrons. They don't have any charge. Okay, they don't have any charge. And then you have the positively charged protons. Okay, protons. And then on the shells or on the orbitals you have what? You have electrons, which are negatively charged, So that means in the nucleus we have what? We have these two guys here, neutrons and protons. Neutrons and protons. Okay, on to the next question. Which pair of substances will react together? Which pair of substances will react together? So let's just analyze this. So what do we see there? From this list, sodium bromine, sodium chloride, that is a salt. Okay, that is a salt. And here you have group 7 elements. Okay, now the reaction between a group 7 salt and another group 7 element is going to be a what? It's going to be a substitution reaction. So this reaction is based off the reactivity. Now we know that in the group 7, the reactivity increases up the group. Okay, therefore whatever you find at the topmost part will displace whatever you find below it. Okay, below it, but you can't find something that is below displacing something that is at the top part there. Okay, let's give an example using the scenarios that we have on the question there. Okay, sodium bromide and chlorine, bromide and chlorine. So Na Let me just confirm something here. Is the periodic table. Okay. Okay, so plus Cl. Now you know that in the periodic table, first comes Br and then you have Cl here. Therefore, chlorine is more reactive than bromine. Okay, so therefore chlorine can displace the bromine. So the reaction is going to be possible. So NaCl plus Br2. Br2. So this reaction is going to be possible. What about bromine and iodine? Now after iodine is somewhere here and then bromine is on top. So in this reaction NaBr plus I2 is not going to be possible because this is less reactive than the Br. So therefore it can't displace the bromine there. Okay? Yeah. So this type of reaction is called a single displacement reaction. Okay, it can also be a redox reaction. It can also be a type of reaction called a redox reaction. Okay, because let's just give an example: NaBr plus Cl2 to NaCl. Okay, now in terms of ions, you know that here you started off with Br as an ion and then it changes to this bromine. Let me just move this bromine molecule. So Br2. Okay, now you know that if you started off as an ion and then you change to a molecule, you'll have lost what? You'll have lost electrons. Okay, you'll have lost electrons. Whereas for chlorine, the chlorine changes from chlorine molecule to chloride ions. You would have what? You would have gained electrons. Okay, you would have gained electrons. So by that definition, gaining and losing of electrons, it's a typical redox reaction. Okay, so the answer for number 23 is going to be A. Okay, on to the next one. Which row consists of gaseous molecules arranged in decreasing order of rate of diffusion? Now, rate of diffusion is directly proportional to what? To the MR. Okay, so the bigger the MR, no, I mean it's inversely, not directly. Okay, what am I saying? Okay, so remember that the rate of diffusion is inversely proportional to what? It's inversely proportional to the MR. Okay, to the MR. So what does that mean? It means if you have a higher MR, your rate of diffusion is going to be very slow. Okay, and then if the MR is small, then your rate of diffusion is going to be fast. So sometimes you use those correlations to be able to explain these things in a more faster way. Okay, the bigger the MR, the slower the something is going to be moving. Okay, so you can think of it as, you know, something that is fat. Okay, if you're fat you can move fast, but if you're slender you can move fast. Simple as that. So we're just going to compute the MRs of those. So CO2, NO2, O2. Okay, so this is going to be carbon is 12 plus 16 times 2, that's 32, and then we get what? We get 44. And then for this guy, nitrogen is 14 plus oxygen times 2 is going to be 32, and then we get 46. Okay, oxygen O2, that's 16 times 2, that's 32. Okay, that's 32. Okay, so let's just arrange this. Which one is going to be the fastest? So remember we have the highest rate of diffusion to the lowest rate of diffusion. So the highest rate of diffusion is going to be the smallest MR, okay, the smallest MR. So this will be first, then this will be second, and then nitrogen will be the last. Okay, nitrogen will be the last. So we go to our options. We're looking for an answer that starts with O2. This is the only answer, followed by CO2, followed by NO2. So the answer is going to be C. The answer is going to be C. 25. The formula of ions of atoms of elements in period 2 are shown. Which statement about these ions is correct? Okay, they have full outer electron shells. Yes, we know that all shells of ions are full. Why? Because during the formation of ions, you are, for metals, gaining electrons. Sorry, you are, for metals, you are losing electrons. And then for non-metals, you are gaining electrons in order to acquire that group 8 configuration. Okay, in order for you to acquire that noble gas configuration. Therefore, your ions will have full outer electron shells. We can also look at the other options. B says they have the same number of electrons in their valency shells. No, they don't. C, they have same number of electron shells. No, they don't, because remember, periods for normal atoms, not for ions, okay? For normal atoms of elements, yes, the number of electron shells will be, because it will be the same, because period, they have the same number of shells. And then for groups, you have the same number of what? Of outer shell electrons, okay? Same number of outer shell electrons. But now, since we are talking about ions, that means some of them will have less number of shells, especially these metals, because they would have lost what? The electrons in that outer shell. And then these ones, the non-metals, they will maintain the outer shell because they would have gained electrons onto those outer shells, okay? Onto those outer shells. And then they have the same number of protons in their nucleus. No, that is totally wrong. 26. Which reaction is endothermic? An endothermic is a type of reaction that needs to gain heat or some sort of energy from its surrounding. Okay, so it's going to gain some sort of heat energy from its surrounding. Heat energy or energy. So the reason we just say energy in general is because not all of the time we are going to be looking at heat energy. Okay, in some reactions we are looking at light energy, in some reaction we are looking at electrical energy. Okay, alright, so combustion, that's an exothermic. It releases energy to the surrounding. Neutralization reaction, a reaction between an acid and a base, that's an exothermic reaction. Photosynthesis, that's a what? That's an endothermic reaction, because you need that sunlight or the light to be used in that photosynthesis process. Respiration, breaking down of or the oxidation of glucose to release energy. So it's exothermic. It's exothermic. 27. Which action will increase the rate of reaction between calcium carbonate lumps and aqueous hydrochloric acid? So here we're just talking about the rate of reactions. So those factors that will affect the rate of reactions. Alright, so we just go through them one by one. A says adding water to the acid, you're actually diluting the acid. So when you're adding water, visually you can think of it like this. Okay, so let's say you have a certain number of hydrogen hydrochloric acid particles. Okay, we'll label them as X. Okay, let's say it's just 4 of them. Okay, now remember, the rate of reaction depends on how many particles are there, and those particles have to be enough, or they have to be closely closely packed enough so that the probability of collision can be high. Okay, so if you have enough number of particles closer together, the rate or the possibility of collision is going to be high. Okay, therefore the rate of reaction is going to be high. Now in this instance, this is the original aqueous hydrochloric acid. Okay, now the rest of the space, where you don't have the S, X, that is going to be the water. Okay, that is going to just be the water. Okay, so now let's say you are to increase the water. If you increase the water, you know the volume is going to increase as well. Okay, we still have the same number of x's. Okay, one x is there, one x is there, one x is there. Now what you can realize is that the space between those particles has increased. The space has increased. Therefore, if I'm to bring my calcium carbonate, so this is the calcium carbonate here, the possibility of this blue dot colliding with the X is gradually increased, sorry, it's gradually decreased here, because now the space between the blue particle and the X has increased. Okay, so therefore the rate of reaction is going to be slow, because it will take time for this particle to ultimately find the X, okay, or to collide with the X, as opposed to this here. Okay, can see here that the space is very minimal. Okay, therefore it will take just a few seconds, or it will take less time for the dots to actually collide with the X, and therefore this reaction will be relatively fast compared to this one. Okay, I'm saying relatively because I'm just comparing these two scenarios side by side. Okay, so cooling the reactants. How does that affect the rate of reaction? Now remember, temperature works in this way. For particles to collide, they will need to have enough energy for them to move about and actually collide. Okay, so therefore the higher the temperature, if you have higher temperatures, then the rate of reaction is going to be what? Rate of reaction is going to be fast as well. So they are directly proportional. The higher the temperature, the higher the rate of reaction. Then the lower the temperature, the lower the rate of reaction, or your reaction is going to be slow. Okay, so temperature and rate of reaction are directly proportional. Okay, so if you increase the temperature, I'm expecting the rate of reaction to increase as well. If you decrease the temperature, I'm expecting the rate of reaction to decrease as well. Crushing the calcium carbonate. Remember, we are looking for an action that will increase. Okay, so we removed this one, okay, crushing the calcium carbonate. Now what does that relate to? It relates to the surface area. Okay, so a crushed calcium carbonate, okay, calcium carbonate would look like this. Okay, so there is more surface area of exposed particles that can actually collide with our acid. Okay, that will collide with our acid. Remember the acid, I'm using that X there. Whereas when it comes to lumps, you'll see that a lump would only expose the calcium carbonate in the respective faces. Okay, so this will be the lump. Okay, so that means the only calcium carbonate that can react will be the ones that are found in the surfaces. Okay, those are the ones that could going to react first. After they have reacted, they can be scraped off the surface, and then the next layer can react until you react all of the calcium carbonate. Now this leads to a decrease in the number of total calcium carbonate particles that are available for the reaction, because remember, in this cube here, some of the particles are logged inside the cube. Okay, the green particles will be the ones that are found in the interior of the cube. Now those particles will not react until all of those that are in the surface have reacted. Now that obviously will take time. Okay, so that means if you crush, you're exposing more particles, that will react than when you have it in lumps. So the answer is going to be C. C. Decreasing the volume of the reaction flask. No, that does not play a role in the rate of reaction. Okay, will not change anything. Remember, for the rate of reaction to change, you're just going to do something to the particles. Okay, you're moving them closer together. Okay, by increasing things like pressure, or you're increasing the number of particles per unit volume. Okay, per unit volume. So you have to directly do something to the particles of either calcium carbonate or hydrochloric acid. Okay, let's continue. Number 28. The ionic equation for the reaction of magnesium and copper 2 sulfate solution is shown. Which particles are reduced? Which particles are reduced? So let's analyze magnesium first. So magnesium Mg changes to magnesium ions. Okay, so now when a metal changes to a metal ion, it does what? It loses electrons. Okay, remember your ionic bond, it loses in electron. So and then we said that the loss of electrons is what? It's oil. Oxidation is loss. Okay, so this is oxidation. All right, so let's see. Copper 2 ions changes to copper 2 atoms. All right, so we'll need to gain electrons. Remember, in a redox reaction, the opposite has to happen. Okay, here we lost electrons. In this other equation, we need to gain those electrons. Okay, so here the copper 2 ions gain 2 electrons to form copper atoms. Okay, to form the copper atoms. So in that scenario, this is going to be reduction. Okay, because reduction is gain of electrons. So these are the two things you can use to remember, all your oxidation and reduction based on the electron gain and electron loss. So therefore, this copper 2 plus ions are the ones that are reduced. They are the ones that are reduced. Mm, 29 says, what is the formula of chloride of manganese in which manganese has the same charge as the MnO2? Same charge or same oxidation. Okay. All right. So let's just deduce the oxidation of that what do you call it? Of that magnesium. Okay. So remember, for us to do that, we know that if this is going to be positive, this is going to be minus. We know that oxygen has O2 minus, and then this one has X, X plus. Okay, we don't know what it is, but we know that after adding, if you add X plus this -2, you get what? You get this +2 here on the oxygen. You get this +2 here on the oxygen. All right, so therefore we just solve for the X. So +2 +2, therefore our X is going to be 4. So we go back and confirm. Okay, we go back and confirm. So if Mn is 4 plus and then O is 2 minus, the 2 positives here cancels with the 1 2 negative, and then you get 2 plus, and then this 2 you bring it to the other side, and then this 1 you bring it to the other side, and then it's Mn1O2. Okay, so we have confirmed that our magnesium has an oxidation state of 4 plus. Okay, so therefore we know that if Mn is 4 plus, then Cl is minus. Then so we take the 4 to the other side, and then we take the 1 to the other side. All right. So the answer is going to be B. Let me just erase this. Number 30 says the diagram shows a set used in the electrolysis of copper 2 sulfate solution. Which ion is discharged at the cathode? At the cathode. So we are electrolyzing, or we're breaking down aqueous copper 2 sulfate. So in aqueous copper 2 sulfate, remember from the water, the aqueous part, you get hydrogen H plus and hydroxide ions, and then from the from the copper 2 sulfate, you get copper 2 plus and sulfate ions. Alright, so what are we discharging at the cathode? At the cathode, we know that the cathode is the positive, is the negatively charged ion, is the negatively charged electrode, so it's going to attract cations, or the positively charged ions. So it's going to attract these two guys. Okay, so you attract the H plus and Cu2 plus. Now what are you going to discharge? According to rules of discharge, you look at the reactivity series. With the reactivity series, you have sodium, calcium, etc., etc., and then you have hydrogen here, then you have copper, silver, gold. Okay, so I'm just going to pick the ones that I have here, okay, which is the copper and the hydrogen. Now when you have hydrogen and the copper, what you discharge, you discharge the less reactive metal. Okay, so in the scenario that you have anything that is below hydrogen and hydrogen, you discharge whatever is below hydrogen. And then in the scenario where you have hydrogen and any metal that is above hydrogen in the reactivity series, you discharge hydrogen. Okay, so if you have a scenario where you have hydrogen and whatever is on top of hydrogen in the reactivity series, you are going to discharge hydrogen ions. Then in the scenario where you have hydrogen and whatever is below hydrogen, you discharge whatever is below hydrogen. Okay, so in this scenario we have copper which is below hydrogen, therefore we're going to discharge the copper ions. Okay, so the answer is going to be A. Which statement about chlorine is correct? It bleaches damp litmus paper. Correct, it bleaches damp litmus paper. But whenever you're writing the test for chlorine, you have to be specific of the type of chlorine, of the litmus paper that you're going to be using. Don't just write any litmus paper, okay? Because the test for chlorine gas, it's a two-step process, okay? It gives two-stage color changes. All right, so whenever you use damp litmus paper, we're going to use damp blue litmus paper. Okay, damp blue litmus paper. So the chlorine reacts with the dampness of that chlorine litmus paper. The damp part, remember, is just the water here, H2O. So this gives us hydrochloric acid plus and hypochlorous acid. Okay, and it also gives us hypochlorous acid. All right, now these, they're both acids, but I'm just going to look at the HCl for now. Now the HCl is going to turn the blue litmus paper red. Okay, it will temporarily turn the blue litmus paper red. Okay, and then the hypochlorous acid will break down, or will decompose to produce hydrochloric acid and oxygen gas. Okay, hydrochloric acid and oxygen gas. Now this oxygen is going to further attack, okay, it's going to further attack this litmus paper, okay, and oxidize it. Okay, when it oxidizes it, the dyes there lose color, and then the litmus paper changes from red to to white. Okay, so in this process we say this litmus paper has been bleached. Okay, has been bleached. Okay, let's go over this again. Now the chlorine gas is tested using the damp blue litmus paper because chlorine gas is a dry gas. Okay, so you need it to kind of like absorb into the litmus paper. This is why we use a damp litmus paper. Now when it absorbs into the litmus paper, it will react with the water to form hydrochloric acid and hypochlorous acid. Okay, now the hydrochloric acid will temporarily change the blue litmus paper red. Okay, it will temporarily change the blue litmus paper red, and then the other acid, the hypochlorous acid, will disintegrate or will decompose to form hydrochloric acid and oxygen gas. Then this oxygen gas will attack the litmus paper and bleach it. Okay, and it will bleach it by oxidizing the dyes that are found in that litmus paper. So the litmus paper finally will change from the red to white. Okay, to white. So our answer, oh, almost forgot. Our answer is going to be that it bleaches damp litmus paper. Okay, it bleaches damp litmus paper. All right. Which equation represents a precipitation reaction? Which equation represents a precipitation reaction? So remember, a precipitation reaction is a type of reaction where you are forming a solid within an aqueous mixture. Okay, so we are forming a solid within a solution. Okay, so whenever you have a liquid like this and then you start forming a solid within that solution, therefore this is the precipitation. Okay, or this is the precipitate. Are we together? Okay, so we're going to basically look for a reaction that can show that. Okay, show that. All right, so for the first one there, you have barium nitrate reacting with the sodium sulfate to form barium sulfate, which is insoluble, and then sodium nitrate, which is soluble. So this guy here is going to come out as a precipitate. Okay, that is a precipitate. It's a solid within this solution of sodium nitrate. Okay, sodium nitrate. And then let's look at the other solutions. Remember, we're only interested in the final product. Okay, our final product has to produce a solid salt within a solution. Okay, a solid salt within a solution. Here, all this will give us aqueous. Then for the second one there, sodium chloride, same thing. Then this one here, the metal here will not be a precipitate, it will just fall to the bottom of the container like this. Okay, as a solid mass. Okay, as a solid mass. All right, let's continue. What is the empirical formula of organic compound shown? So empirical formula, remember, it's a simplified molecular formula. So first we have to generate the molecular formula. So C, we have C2H 1 2 3 4 O2, and then we can simplify this C1H2O. So this is going to be the empirical or the simplified molecular form. So the answer there is going to be what? It's going to be A, number 83. Okay. Number 34. What is the concentration in mole per cubic decimeter of 250 cubic centimeter solution containing 0.5 grams of sodium hydroxide? We are looking for concentration. So first we're going to calculate the number of moles. Okay, so we use the triangle for reacting solids or reacting masses. reactive masses. So we have mass here, N here, Mr or Ar. In this case, we have Mr. So therefore, N is equals to mass over Mr, which is equals to, our mass is 0.5 over Mr is 40. Then you find 0.0125 moles. Okay, so those are the number of moles. Then remember that concentration, this is the formula. In there are units, but they are it's the formula. You have N over volume. Okay, so concentration is equals to moles over volume, which is equals to, let's just quickly change our volume. Remember, our volume is to be in cubic decimeter, whereas in this scenario it's in cubic centimeter. So let's just quickly change that. So we change by dividing this by 1000. Okay, so divide this by 1000, you get 0.25. Okay, 0.25 cubic decimeter. Okay, N, let's go back to this. N is, we found N here, 0.0125 divided by our volume, 0.25, and then the answer is going to be 0.05, 0.05, which is D. On to the next question. Which statement explains the unreactivity of aluminum metal? Is because it has a coating of aluminum oxide. So now when you're looking at a piece of aluminum metal, just have to remember that it will always have that layer, have the outer layer of aluminum oxide. Okay, Al2O3. Now this layer is works to the advantage of how we use metals. So it's an advantage because it protects the inner fresh. Okay, so it protects the inner fresh aluminum metal from further oxidation or reaction with the atmosphere, okay, or other elements, okay, like water, which can react with the fresh aluminum. Number 36. What are the types of oxides formed by aluminum, sodium, and sulfur? So generally speaking, group 1 and group 2 will form your basic oxides. Remember, I'm saying general because some will stand out. Some elements in those periods will stand out and not give you this kind of like a cheat code. Okay, and then the amphoteric oxides are for aluminum, zinc, what's that one? Let me just use the periodic table. Yeah, but for our syllabus, let's just stick to aluminum and zinc. Those are the amphoteric oxides that you'll come across. And then the neutral oxides will be oxides or dioxides of non-metals. Okay, dioxides of non-metal. Carbon dioxide, nitrogen dioxide, the dioxides. And then for the monoxides, there will be neutral oxides. Okay, there will be majority of them will be neutral oxide. Carbon monoxide, water, which is a dihydrogen monoxide there. Yeah. And then which one did I forget? Okay, let's take it there. Okay, so the answer is going to be D. Sodium, group 1, basic oxide. Aluminum, amphoteric. Amphoteric are type of oxides that behave, they have properties, or they behave like both basic and acidic oxides. Okay, then acidic, they behave like acids in reactions. Basic, they behave like bases in reactions, in chemical reactions. 37. Which group of organic compounds can undergo addition reaction? So the group is going to be alkenes. Okay, alkenes. Why? Because alkenes have that double bond. Now that double bond, you can change it into a single bond. Okay, so when you change it, let me just do this one properly. So if you have a double bond like this, okay, so I have a double bond like this. If I change the double bond to a single bond, that means this becomes single bond, then I'm still having those. Now you need to know that one carbon can take a maximum of what? Can take a maximum of 4 single bonds. Okay, 4 single bonds. So that means I have created an extra room to add, another single bond. So in those new single bonds, that's where you can add things. Okay, you can add other elements. Okay, you can add other elements there, or other atoms there. Okay. 38. Which polymer has ester linkage in its structure? Which polymer has ester linkage in its structure? So the answer is going to be pterylene. Okay, this is going to be pterylene. Nylon and proteins, they have what? They have an amide linkage. Okay, they have an amide linkage, whereas pterylene is the only one that has an ester linkage. Okay, an ester linkage. So for our syllabus, carbohydrate doesn't have the linkage that you find there is not really defined. Okay, it's not really defined. So it's neither amide nor is it an ester linkage. 39. The equation shows a reaction in which simple sugar is produced. Which type of process is shown by the equation? Remember, sugars are produced from complex carbohydrates or starch. Okay, so here we're doing what? We are going to be breaking this complex structure. Okay, we break this complex structure using water to form simple sugars. So whenever you're breaking down something, like you have that lysis in there. Okay, means you're breaking down something, like electrolysis, the breaking down of ionic compounds in molten or in aqueous state. Okay, then here we are using what? We're using water to break down that complex molecule. So hydro for water. Okay, for water. So the answer here is going to be C. The last one, 40. The table shows the results of tests carried out before and after boiling on some water samples X and Y. So which salts are most likely to be present in samples X and Y? Okay, what's happening at X? What's happening is that before boiling, you needed 10 drops of soap, and then after that you needed just one. Okay, so that means boiling has an effect. So remember that this salt, calcium or magnesium hydrogen carbonate, is the only one that will respond in this way. Okay, why is that? It's because when you heat this salt, when you heat water with this salt, the salt will decompose to form calcium carbonate plus H2O plus carbon dioxide. Okay, now this calcium carbonate will do what? Will precipitate out of the water. It will precipitate out of the water. This is what you usually find around the kettle element as a scale. Okay, so by doing this, you have actually softened the water. Okay, you have softened the water because you have successfully removed the calcium salt from the water. Okay, therefore the water will now change from temporary hardness in water to now being soft water. Okay, right. So that means our answer for whatever is happening in the side has to be a salt that is responsible for temporary hardness in water. Okay, temporary hardness in water. So which is only this guy according to this. Then sodium chloride. Yes, sodium chloride does not cause hardness in water. Okay, does not cause hardness in water. So the answer is B. And then for permanent hardness in water, remember that you're looking at calcium or magnesium or magnesium sulfate. Okay, calcium or magnesium sulfate. Okay, this one will be responsible for permanent hardness in water. Why is that? It's because even if you try to heat this salt, it will not decompose like we have here. Okay, it will not decompose. So you need special methods of treating the permanent hardness in water. Okay, so like your ion exchange. So those are some of the options that will be available to treat that type of water. All right, thank you guys for attending. I'll see you on the next one.